Assalamualaikum, I'm Ahmad Dani Zainuddin. I'm from Universiti Malaysia, Pahang. Today I want to present about 5S and Kaizen methods. My supervisor is Professor Madya Technologist Dr. Muhammad Haji M.M.Noor. So what is 5S and Kaizen? 5S, the definition of 5S, it is traditionally to organize physical space and items. In philosophical, it is some sort of positive behavior and a discipline that can be and must be implemented in organization and staff between any other layer in managerial or operational. It is one of lean manufacturing tools. It's like just-in-time, Kanban, quick changeover. It is to reduce waste and minimize resource consumption. So what is the concept of 5S? The concept is it has its own origin in socio-historical and philosophy fields. So 5S is a Japanese thinking which is to balancing between philosophy and technique and is used to coach the body and mind through discipline. So this chart is about 5S, Seri, Saiton, Seiso, Seiketsu and Shitsuke. So I start with Seri. Sort, we want to eliminate some kind of unnecessary tools, equipment and furniture from the workplace. Second, set in order. We want to make sure everything is kept in place whenever we start the process or after ending the process during manufacturing or production. Say so is shine. We want to make sure the cleanliness of the workplace create safer workplace. We want to make sure no hazardous to make sure no hazardous in the workplace, to make sure no injury might happen during work process. So standardize. We want to standardize the process to maintain the previous step, just like Seri, Seton, and Seiso. Shisuke sustain or self-discipline is some sort of form of habit of continuous improvement. So we can see here, Seri sort, we keep everything in its place. Seton set in order, and Seisho shine. We want to make sure the machine keep uh, keep in good condition, and Seiketsu standardize, Shitsuke sustain. Make sure the previous step is continuous to make sure improvement. So what is Kaizen? Kaizen in English, it is basically from Japan. Kai means change, Zen is good, or as I say, continuous improvement. It is a philosophy originate from Japan that encourage small improvements obtained through continuing effort. It is successfully implemented by Japanese industry since World War II. It is to enable people to be much flexible in relation to change occurring, thus incorporating such changes in daily routine actions. So in this chart, act, plan, do, and check, it is required to breaking the traditional mindset and encouraging employees to adapt a new mindset, support the desired behavior, the plan, do, check, act, problem solving cycle is used. So you can see here Mr. Churchill, as you said, attitude is a little thing that makes a big difference. It's related in Kaizen. Requires breaking the traditional mindset to have a new mindset to support the desired behavior. So what about Jidoka or Anden? So Anden from Japanese words means paper enclosed lantern. So Jidoka is from Toyota Production Management. It is one form of there are two pillars to resolve and prevent the occurrence of defect production. So Toyota is they really caring about their quality. So in Aden we have three spots here: alert, signals, and resolve. So what about the method of Anden? So Anden cord is a rope or cable hanging along the production line. The operator has a full full power to pulse to stop production, or otherwise signal that there is an issue. So enter button is an alternative signal form of signal. Instead of pulling the cord, the operator presses the button. This is much practical than add-on cord. Buttons have the advantage of making it easy to select from multiple status options. This means if a product starts to defect uh, in a different defect, so the operator can use a different button depends on the product defection. So they can choose any button they want to choose according to the defects product. So whereas and codes typically simply stop the line. So and then sounds is frequently used as a supplemental form of alert. It will start to alerting everybody in a production line, especially to call attention to extended periods of downtime. The sound can be a buzzer, maybe a tone, or maybe a short melody, or even a pre-record verbal message. So the signal here to empower operators to stop the line because of an emergent problem. They pull the cord, so the alert will start to make a light, probably a sound as well. So to resolve to encourage operator and supervisor, maybe manager or technician, to work together to resolve or finding the root cause of the problem and implement for a long-term fix. So what is purpose of this ending? It is to create a product with 100% good quality, to make sure the product is 100% good quality. It is also to prevent a part shortage, equipment malfunction, or safety and quality concern, and resolve them before resuming the production. So how it is work? So when operators start to apply the button, any button that they want to choose, as I said, depend on the product effects. So the process will automatically stop. Operator given this statement, operator given full authority to stop the production process in the case abnormality happens. So they use their own visual to spot the abnormality on a product. So the stop, call, wait process. So as from the first steps, the production will stop when the abnormality occurs. Then the operator will start to call requesting a support from the group leader. So in this moment, the group leader will start to call a manager, technician, machine technician, or maybe supervisor, as I said from earlier, to find root cause of the problem. So in the wait process, it is for support to arrive before proceeding. So the production line will stop the process for giving the upper level to find the root cause. So visual control system, they will observe any uncommon problem. It probably variable, probably more variable parties involved will be the section head or supervisor to handle the major problem. So what about Pokayuki? Pokayuki is some sort of system created by Shiego Shingo. As he mentioned, making mistake is part of humanity. Mistakes are inevitable. It is imminent, will happen, but the defects that arise from them are not. So Pokayuki is a mechanism used to eliminate errors by effectively making it impossible to make mistakes in a given process. And they can be used everywhere, whether it is from plug suction, or maybe a card, or maybe a dice in a manufacturing parts. So what is the original name? The original in English, it is mistake proofing. In Japanese, Pokayuki was foolproofing. So it is part of continuous improvement or Kaizen. So we can see here, it is a traditional C card. This is might be can give a confusion to the user because of maybe they can use it maybe in an upside down, or maybe in the right place. So to clarify it, to give irregularity in a Pokayaki, they cut the object here 2.5, so make sure the user will not making any mistake. So this is a format about causes of defect in error. You can see here what is the cause of a human error in Pokayaki. So the first one is not following procedure. It can be intentional error, forgetfulness. It is from human errors. Okay, one of major factor causing defect product. Inadvertent error. So what about processing error? Of course, probably from intentional error. This is bad. Intentional error is bad. Misunderstanding and inexperience or lack of skill, willful error, slowness. Slowness is one of major factor in a bottleneck in a production line. Non-supervision. This is one of responsibility in our employees. Missing part. Yes, that wrong parts. This is you can see here. Any kind of factor here play a big role, and what cause of defect, misoperation, and so on. This is strongly connected in the black mark. So what about we can use tools from Six Sigma, which called this Ishikawa diagram, used to analyze the cause. You can see here one of the big factor we can use is 6 factor from what makes the problem happen. You can use measurement, methods, machines, mother nature, material, and man. So what about man? Employee fluctuation, no incentive, inexperience, a common problem, no supervision. So from the material here, we can see quality of resource, damage, worn materials. What about mother nature? It's about environment, bad environment, air pollution, waste management, bad waste management. Machines, obsolete machine misuse, this is common. Methods, no guidelines, or we can relate to with no supervision. That's one of the major factor of defect product, not complying to SOP. As well, no supervision, we can relate it here. Measurement, no systematic measure, and inaccurate. So to analyze any defect occurred by human factor, cause and effect diagram are simple problem solving. It can be used by teams, individuals to brainstorm and identify the root cause of problem. So Ishikawa diagram is good tools. Can be used to identify. So what about the method? The method about Pokayake here is a motion sequence, contact and counting. So in contact method, it is function by detecting whether sensing device make a contact with a part object within process. So in next slide here. So this is the machine, the parts used here to contact any defect depth here. Let's say this is a zip tie produced by a manufacturer. So we can see here, if the machine here, if the pole here start to touch the cylinder, that means the zip tie is in good condition. If it is not detecting or maybe touching the zip tie, then the process will stop. Then the alarms will start to make a sound. So this accounting method used when a fixed number of operations are required within a process, or when a product has fixed number of parts that are attached to it. So this is use a transmitter, use a radar to detect the object. So this counting method used in a fast-paced production. So the transmitter will start to the light here will start to detect the object, then it will transfer the data to the receiver. It is used in mass amount production to avoid extra part produced by the machine. So if the operators find parts left over using this method, they will know that something has been skipped from the process. So this is a motion sequence. It is used sensor to determine of a motion or step in the process has occurred. If the step has not occurred out of sequence, the sensor signal a timer or other device to stop the machine and signal the operator. So this is motion sequence. Use a signal when a machine start to detect something bad happens, something defect will happen. So this indicator board will show what's the problem is going on. Of course, the machine will stop as well. So what about egg waste? Lean waste is designated in Japanese as a muda, and it is considered by Russell and Taylor to constitute anything other than minimum amount of equipment or materials, parts, space, and time which are essential to add value to the product. So what about non-value added, or as I said, waste activities are not regarded as essential, which customer would not be prepared to pay. It is essential, or as I said, need to comply to be eliminated or probably reduced to a minimum in the scope of a process improvement. What about value added activities? It is have a positive effect on the product service that raises its value to the first time they perform. The customer probably will pay for it, or probably will want to pay for it, or want to pay for it. What about this value enabling activities? Activities which do not add value per se. At least supportive process performance, it is best to minimize these activities. So value enabling activities might be adding a value to the activities, but it is not giving a big positive impact to the product. So it is best to minimize it. So we can see here, prior to improvement, we want to improve these value added activities and minimize the value enabling, and of course we want to reduce it, probably eliminate the non-value added activities. So after improvement, you can see value added will increase by using a Ishikawa diagram to detect the defect or what the cause of it, minimize the non-value added. So we can see we want, of course, to minimize value enabling activities and eliminate non-value added activity. So this is 8 types of waste: overproduction, product effect, overproduction, and waiting time. This is common. Um, Always happen when we want to resupply the resource. Waiting time might be happen. So this is what we call a waste. Processing times, just like from earlier, when something defect happen on a product, so we will stop the production process. So in motion waste, this is related to the operator. Maybe the operator is himself inexperienced, lack of skills, or maybe not following the SOP. So the motion waste of motion will start to happen. Inventory, unlabeled inventory, and transportation. So according to Taichi Ono, so this is muda, an unreasonable burden on people or machine, or as I said, a motion waste or probably processing waste. It is related. So mura, unlabeled workload on people or machine. So probably we can see this guy. We can say this guy is experienced, maybe 4 or 5 year experience. Then they will start working together with inexperienced worker. So we can see they will start to burden. So mudah any form of waste in process. You can see there all three of these phenomena are disruptive to efficient production operation. So another new type of waste is unused human potential or talent, or maybe unnecessary skill. It is inappropriate use with resource, high consumption of energy and water, or material effort. So what about quick changeover? It is created by Shigeo Shingo. These techniques developed by Shigeo Shingo for quick changeover between products by simplifying materials, machinery, process, and skills. Changeover times could be reduced from hours to minutes. So this method can be translated to tool change in less than 10 minutes. The purpose of it to fundamentally to reduce series changing time. So why we use this method? It is to eliminate the waste of waiting in the process that is inherent with long setup times. Of course, we want to reduce the waste of inventory by running smaller batches, but using faster setup times. So during the process, when machine is not running, it is important to start to quit changing. When operation setup while the machine is running, of course we want to do the changeover as well. So what about the examples? We can use F1 pit stops. As technology changes, we can see how much quick changeover can affect time consumed on managing the works to execute. So on the next slides, the graph to depict the timeline of the average pit stop time during races from 1950 to date. So we can see here about this graph. This graph here, how much time consumed to change a tire, and how much time consumed to reload the fuel. You can see here when in 1950 we know the technology is not faster like today. It is approximately about 60 seconds to complete the process. So you can see here it start to reduce. Then the time start to become much efficient and much faster. Maybe in next 4 to 5 years, probably we need about 2 or 3 seconds just to change a tire. So I want to show about a video. I hope you can see here. So this video about from time to time, when in 1960 to 2000.
Time to refuel and change tires. Noor himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's the 10th time. Holland stays in his seat, anxious to get away. Let's watch.
So we can see here from the first operator, in this video we can summarize that in this first video clip, we can summarize that technology is important as time goes by. You can see how much time does it take to change just in one tire.
The tires are changed to glass. A crewman polishes the windshield as Holland moves away just 67 seconds after he stops.
It takes to change just a 2 tire. So what about this time, this technology? You can see here. all of the pit stopper are ready to start change service. Just about 3 seconds it takes to change 4 tires and clean the windshield. You can see here how much important is quick changeover in a manufacturing or probably in operational procedure. So this is a few example about quick changeover. We separating 2 dice to 1 trolley. So that means 1 dice here, another dice here. We want to change the first die to second die. So in without a changeover, we use 1 trolley. We use 1 trolley here. So we start to remove the first die. This is 1 trolley, right? Remove first die, then the second die goes from here then to here. It takes probably about 10 seconds or probably more. So with quick changeover, we use two trolley, one here, two here. So we change the first die from the machine, one to here, then the second to here, to the machine. It takes much lesser than the first picture with slow changeover, poor positioning of dice. So we can see here philosophy to 4 stage. Our setup is combined. There is no difference between internal and external work. Okay, I don't have to explain too much. So ICC, innovative and creative circle. So it refers to a small group of workers from the same work unit or across departments who meet regularly to identify, select and analyze problems associated with work and submit a proposal to management for consideration and to carry out the suggestion once approved. So we can see the cycle here: innovation, creative outcome, impact, enabling power. So the purpose of ICC is to brainstorming a new idea, select or probably identify, select and analyze, and improve it to best and prolong process. So here's another tool: PDCA, plan, do, act, check, 5W, what, why, when, how, where, much, and or and who. So we can use a process flowchart analysis. It is to reduce any waste, any motion waste, probably waiting waste. So here we can use pie chart. We can relate it with Pareto chart, dot plot, and so on. So the MAIC from Six Sigma, we can use this tool in ICC. 3S means mapping and safety patrol. So as I mentioned from earlier presentation, it is some sort of discipline or positive behavior. Second is systematist, putting every necessary items in good order and focuses on efficient and effective storage method. The main purpose is to eliminate all unnecessary items from the workplace and decide whether the place of everything is attending to the workflow or not. It is good to taking before photographs whenever it is necessary. So another discipline behavior is say so, sweep. After done doing work, we start to sweep, put everything in its own place, everything, keeping the workplace clean and inspect the workplace and equipment for defects. So Shizuke self-discipline represent a set of activities to ensure the respect of the 5S standards, making a habit of maintaining correct procedures. The result is producing a positive consequences of keeping the procedure. So here's the reference. Okay, thank you very much for today. Thank you for listening.